Assalamualaikum. Welcome to another video. In this video, we'll be doing another question related to kinematics, which includes graphs. So we have the question in front of us. The question, figure 1.1, shows the distance time graph for two cyclists A and B. They start a race 500 of they start a 500-meter race together, but finish the race at different times. So use figure 1.1 to determine the distance between A and B at time t equals 0.2 seconds. So the question is simple. This is just about reading the graph. The time t equals 0.2 seconds. This is where the line is. If I locate cyclist A has moved a distance of 200 meters since the start of the race. And at the same point, if I carry on the line and I try to locate A, cyclist A happens to be at a point which is about 260 meters. How did I figure out it's 260 meters? It's simple. It's a simple way. We're just gonna need to count the boxes. So this is one box, two box, three box, four box, five box. Sorry, that's not how we count them. This is one box, two box, three box, four box, five box. So we have five boxes, and five boxes represent what? 100 meters. So it's quite obvious that a single box would be representing, if five boxes represent 100 meters, it's quite easy for me to deduce from the information that five boxes equals 100 meters, then one box would be equal to x meters. So it's a bit simple to reduce from this point. We could just cross multiply them, and we'll just simply get, or even no need to cross multiply, just we can figure this out by observation, that every single box, one box would be representing 20 meters on this line. So since the point A is about three boxes above the line, above the 200-meter line, so that's 3 times 20, which is 60. So 260 meters. So cyclist A is at 260 meters from the start of the race. That's how much he's traveled. That's how much far away he is from the starting point. And B is at a distance of 200 meters from the starting point. So what's the difference between both of them? That's just simply 260 minus 200, which is equal to 60 meters. So that's what your answer comes out to be. I hope this part is clear to everyone. And the next thing is the difference in the time taken by A and B for the race. This is again simple. Participant A completes the race at this point, which is a time equal to around 38 seconds. I've applied the same rationale that five boxes represented 10 seconds, so one box will represent 2 seconds, and since it's four boxes after 30 seconds or one box before 40 seconds, the time is going to be equal to 38 seconds. So cyclist A completes the race at 38 seconds, and cyclist B completes the race at 50 seconds. So the distance between 50 and 38, that's simply 50 minus 38, which is 12 seconds. So that's my answer. Cyclist C starts the race at the same time as A and B, and covers the first 200 meters of the race at a constant speed of 5 meters per second. He then accelerates and finishes the race at time t equals 6 seconds. Time t equals 60 seconds. Now the distance time graph for cyclist C. Now just hold on with me how to solve this question. We have some information with us that the first 200 meters are covered with a constant speed, which is equal to 5 meter per second. That's what we know. After this point, till time t equals 60 seconds, he accelerates. So we just need to draw the speed time graph for the person. Before I could jump onto the speed time graph, I need to see how much time is the first period. Like how much time does it take for the person to move 200 meters with a constant speed of 5 meters per second. So before I go on to that, I'm going to erase all of this from the board, so the graph is clear to me and I could just simply easily draw participant C. So now, if the formula we've always used for speed is speed equals distance over time, and this formula is only applicable in cases where the speed is constant, and this is what we've used in previous grades, and we assumed that the speed was constant, though it was not clearly mentioned. But now when we now studied acceleration, this formula, just remember, only is applicable when the acceleration is zero or the speed is constant. In this case, the speed was constant and he travels a distance of 20 meters, 200 meters. So we could just simply find the time with the formula. 5 equals 200 over time. I could just simply rearrange and I could get t equals 200 over 5. And this would just simply give me 40 seconds. So for the first 40 seconds, he goes with a constant speed of 5 meter per second and travels 200 meters. So I just simply go onto the graph and I mark time t equals 40 seconds and time distance 200 meters. This comes out to be my point. What I do next is I make a line, a straight line. Okay, so distance time graph. The gradient of a distance time graph equals speed. Now we need to draw a line from time t equals 0 till time t equals 40 seconds and distance equals 200 meters, which represents constant speed. The gradient of a distance time graph is equal to speed, and a straight line represents constant gradient. So a straight line on the distance time graph, a non-horizontal straight line, would represent constant speed. So that's what I do. Just simply draw a straight line from both the points and I make the line. Now what do I do next? Now I'm done with first part of the graph, or the first information they've given me. Now they tell me he then accelerates and finishes the race at 60 seconds. At time t equals 60 seconds, he finishes the race, meaning he has suddenly reached the 500 meter mark. He goes there. Now I need to join the two lines, but I need to join the two lines in such a way that it represents acceleration. I can't draw. Whether I should draw. There are like multiple ways. Like one could be draw a straight line. One could be draw a line like this. One could be draw a line like this. So there are multiple ways how I could do this, but I need to figure out which one would be the correct way. So the keyword is during this time, from time t equals 40 seconds to time t equals 60 seconds, the object or the car is, or the cyclist is accelerating. Now acceleration means that the speed of the object is increasing. So now when the speed of the object is increasing, how would I represent it on a distance time graph? The gradient of a distance time graph is speed, and if the speed is increasing, I have to draw a line which represents increasing speed. Yeah, so increasing speed or increasing gradient. So if you remember, the graph for increasing gradient looks something like this to us. So that's how I do this. That's how I extend the line and I eventually reach to the point there. Or let me make the lines a bit dark. So yeah, this is how I go, and the graph needs to stop at 500 meters because that's the point where he finishes the race, and I need to show that in my answer. Okay, so now moving on to the next question. Calculate the average speed of the cyclist C for the whole race. So now if I look at the speed time graph, the cyclist takes a time of 60 seconds to travel a distance which is equal to what? 500 meters. So this is the information I have. Now the formula for average speed, if you could recall, is average speed equals total distance over total time. So the cyclist took a total time of 60 seconds to travel a total distance of 500 meters. So the average speed could just be 500 divided by 60. And this gives me an answer of 8.33 meter per second. So here I go with the average speed, and that's what I write, 8.33 meter per second. Now one thing to just keep in mind when answering or when writing the final answers, never forget to write the units. If you forget the units, you lose the mark. The second thing is Cambridge only accepts answers, or it's better to write answers either in terms of two significant figures or in terms of three significant figures. Two significant figure is how Cambridge marks the question, but it's better practice to have three significant figures written in your question. So that's how you're supposed to do it with three significant figures. 8.33 is three significant figures. Although the number initially had extended beyond this 8.33333, they're like infinite threes there. But I just restricted my answer to three significant figures. So that's how I do this. I hope this is clear to everyone. In case you